Alright, let's have a look at the chapter 4.4. So, in this chapter, we're looking at graphing cubic polynomials. Now, the general equation for a cubic polynomial, like our quadratic, this time we've got cubic, so powers of 3. Very similar, so ax cubed plus bx squared plus cx plus d. So, basically, for the powers of 4, it would be just very similar. So, an example, so if we had that'd be ax4 plus bx cubed plus cx squared plus dx plus e. Okay, we're just adding letters to the end of the equation. We're not going to look at that. We're just looking at powers of 3. Okay, our a, b, c, and d are real constants, and we have a is not equal to 0. Because if a was 0, we'd have a quadratic. 0 times x cubed, well, it's just bx squared plus cx, okay? Not going to help us that much. So a has to be, well, it can be less than 0, it can be greater than 0, it just can't be equal to 0. So let's have a look, okay, the general graph, what it looks like for x cubed. And basically it looks like this. Okay, y equals x cubed. Alright, we're going to look at dilations and translations and all that, but to start with, like our quadratic generally looks like that to start with, and then we moved it up and down, left and right. Okay, similar case for this, and that's our general equation. So some key features, we've got one intercept. We go from concave down to concave up, okay, going down and then up. Down to concave up. We've got a stationary point at 0, 0. What's called a stationary point. We'll be looking at those shortly. So that's basically when we go from concave up to concave down, or other way around. So if we're going concave up to concave down, same thing. A stationary point is that point where it flips from one to the other. Okay, the values of x become very large, positive. So as we move across, our numbers of x are actually going to be very large as we go from left to right. Compared to our quadratic, it's going to be a lot bigger at least. So for example, if we have 3 cubed, well, that's 27. Compare that to x squared, which is 9 for the same point. So quite large compared to the x squared graph. And same thing for the negatives. So if we go backwards, so minus 3 cubed, well, we're actually going to get negatives here. So minus 3 cubed is minus 27. Compare that to the x squared graph where minus 3 squared is going to give us 9, a positive number. Okay, so as we move across left or right, we're going to get large numbers either way. And the last thing is for a general equation, or our general graph, we start from below the x-axis. I should have labelled those. So we start below, okay. So there are a few key features. So next part we'll be looking at dilations and translations. So just keep in mind that's what our general equation for x cubed graph looks like.